Okay, we're going to look at vectors today, and we're just got to figure out how to draw these properly and then do the math to solve them. You're going to see that the math that we do is just basic right angle triangle, so it's pretty straightforward. And so the math is going to be simple. You just got to be really careful with your diagrams. So the first example, I'm just going to do a few questions off the worksheets, the one that has the velocity vectors, the first one that's down below. It says a car is traveling in a straight line with uniform motion. The east component of the motion is 15. So what you want to do is make sure you draw that properly. So draw your vector at 15 meters per second. And then it says the south component is 11. So when you're drawing vectors, you always want to draw, so draw your first one, put the arrowhead so you know which direction it's going. So this one's going east. Then you want to start your second one from where that one ended off, and then go south. So in this case, we'd have 15 east and then 11 south. So the question is, what is the velocity of the vector, or what is the resultant? So when we do resultant, that's always going to be from where we started to where we ended. So the resultant in this case is the blue line. Okay, so that'll be what you actually are moving. So instead of saying I went east and then south, we could have just went at an angle in the straight line that the resultant shows. So when you're doing these, you can see it's just a basic 90-degree angle triangle, but because it's vectors, we actually have to find the length of the side. So we have to find that side there, and we actually have to find the missing angle. So you have to do both. So the first part of it, let's do the side. So you can see, because it's a right angle triangle, you can just do Pythagorean theorem. So x will equal the square root, right? It's a squared plus b squared, so 15 squared plus b squared would be 11 squared, and then just square root your answer. So when you go 15 squared plus 11 squared, do that on your calculator, and you get 346, square root that answer, and we get 18.6. Go back to the question. The original question was 15.0 and 11.0, so we had 3 sig digs, so we should keep our final answer in 3 sig digs as well. So we have 18.6 meters per second for our vector size, but like I said before, we have to find that angle. So if you look at the angle, you can see we've got our opposite side is 11 and our adjacent side is 15, and we just calculated the hypotenuse. So technically we could use any of the sine, cos, or tan, but just like before, it's better to not use your answer you calculated just in case you made a mistake. So in this case, if we were to just use the one that we know, we'd pick tan, so we'd have tan of the angle is opposite over hypotenuse, so 11 over 15. And remember, when you're looking for an angle, the way to solve it is you have to do second tan. So on your calculator, go second tan, 11 divided by 15, and that's it. So if you go shift tan, 11 divided by 15, you should get an answer of 36.3 if we round it off to 3 sig digs, so 36.3 degrees. Okay, so that's good. We've got everything figured out, but there's one more step that you have to do, and that is actually write your answer in final vector form. So we'd have 18.6 meters per second and then we say what direction it's at. So our answer was 36.3, so you just got to add in the north, south, east, west, or you could use the math version that we did the other day. So in this case, let's do the north, south, east, west first. We went east, so we started off going east, then we went down at an angle of 36.3 degrees towards the south. Okay, so that's one of the answers that'd be acceptable. Or if you wanted to, you could do the math way, so it would be 18.6 meters per second. And for an angle, remember it's from the 0 line all the way around, so you'd have to go 0 all the way around to that angle, so you'd actually have 360 minus 36. So that would give us 3 323.7, but we'd round it to 3 sig dig, so we'd have 324 degrees. Okay, so either of those two answers would be acceptable for this question. Let's try one more. Let's do question number 3 that's on there. So it says an airplane is headed due north at a speed of 32. Okay, so we got one that's going straight north, 32. And it says a wind is arising from the west, which means it's blowing east. So be careful with these kind of questions when you see them. Whenever they say a wind, they say a westerly wind, that means it's from the west. Or if they said you have an east wind, that means it's going from the east, blowing towards the west. So just be a little bit careful when you do those directions. So this one we have 32 to the north, 12 to the east. So the question is, what is the resultant velocity? So we want to go from start to finish just like that. So we want that side and that angle. So we just do the exact same thing we just did. So to get the side, we would go Pythagorean theorem. So 32 squared plus 12 squared, square root that answer, and that should give you 34. It works out to. Okay, and then for the angle, go second tan of 12 divided by 32. And that should give you, we're just doing 2 sig digs in this case, so you should get 21 degrees. Okay, so those are our two answers. So now, just like we did before, you want to make sure you write them properly. So you'd have 34, our original question was in meters per second, so we'd have 34 meters per second. And our angle would be north 21 degrees east. Okay, or remember, we could use it the other way. We could write it as 21 degrees east of north. Or if we wanted to use the math version, it would be from the 0 line up. So it'd actually be 90 degrees minus the 21, which would be 69 degrees. Okay, so any of those 3 directions would be acceptable. Okay, and then you could actually do other ones. You could say east, 69, north. That would be fine too. So a few different ways of expressing answers. It really doesn't matter. Just pick the one that you're comfortable with and go from there. The next thing we'll look at, so we'll continue with this, is what happens if you get questions that are in the reverse order. So this is the second worksheet, the one that says components of vectors. So people tend to have a little bit more trouble with going backwards. So what you want to do with these is make sure you draw your original vector perfect, so to start with. So we're going to look at 1b. So it says 16 meters, 16.0 meters at 27 degrees east of north. Okay, so there's the question, and what we're looking for, what are its components. So when they say components, what they mean is what are the horizontal and vertical components, so the parts that are going north or south and the parts that are going east or west. So we want to basically take the answer now and work backwards. So with these ones, just make sure you draw them correctly. So let's sort of do a little grid so we kind of starting in the right direction. So if we're going east of north, that means we should be going something like that. So that 27 degrees would be down there. The length of our line is 16.0. So our components would be a north component, and then we should have our east component like that. So east of north means we went north first and then to the east. Okay, so there's our diagram. So now all we have to do is figure out what each of those sides are. So you can see here we're just using regular trig again, except this time now we have opposite and adjacent. So let's call our adjacent side the vertical side y, because that's typically what we use. And then for our horizontal, let's call it x. Okay, so we just want to find each of these. So you can see from the angle we have opposite and hypotenuse. We can just use regular sine. So sine 27 is opposite over hypotenuse, so x over 16. So to solve that, all we have to do is go 16 times sine 27. So do that on your calculator, and you get, we round it to 3 sig digs, because that's what the question was, there was actually a 27.0. So everything had 3 sig digs, so we should get 7.26 meters. And that was our horizontal component. That's the one that was going east, so let's add east on there. Okay, then we do the same thing for our vertical component. So we have the adjacent side this time, so we're going to use cosine. So cos 27 will equal y over 16. So we'll cross multiply those ones, so you'd have 16 times cos 27. So when you do that on your calculator, we get 14.26. So we'll round it to 3 sig dig, so just 14.3, and that one is the one that's going vertically, and we're heading north, so we'd write it as north. And that's it. So when it asks for its two components, that's all you have to do, is do the sine and cosine for each, and make sure you got the east or west figured out and the north or south figured out. So let's do one more. Let's look at we'll look at number 3. It says a ball is thrown into the air at an angle of 40 degrees to the horizontal. So 40 degrees would be something like that. So there's our 40 degrees. So the question is, it's saying it's going at 25.0 meters per second, and ours was 40.0 degrees. So we have 3 sig digs. So the question is, what are its components? So we want to find the vertical and the horizontal. So the question is, should we draw it east first and then north, or should we go north and then east? And it really doesn't matter. It'll work the same either way. You just got to pick one and make sure you have the right angle. So in this case, the way I drew the 40 degrees, it's better to draw the triangle like that. If we wanted to do, let me just show you the other version. If we drew it like that to be the 25 degrees, and we wanted to draw the vertical and horizontal to look something like that, then the only thing that would be different is we'd have to figure out what that other angle is. So if it's 40 degrees up, that means we'd have 50 degrees there, and there's 25 would still be there, and we'd get the exact same solution. So it doesn't matter which one you pick, just make sure you have the angle properly calculated. So for this one, let's do our horizontal component first. So it's our adjacent side, so we'd have cos 40 equals x over 25. So when you do that one, you should get 25 times cos 40 gives us 19.2 if we round it off to 3 sig digs. So 19.2 east. And then do the same thing for the y component. The vertical components, we'd have sine 40 equals y over 25. Cross multiply those, and for y we should get 16.1. And I forgot to write the unit, so it should be 16.1 meters per second, and this one is going north. Okay, so on the previous one I should have had meters per second as well, 19.2 meters per second heading east. And those would be your two answers. That would be all that you have to do for the question. Okay, so that's it for the components. We'll stop there, and then next week we'll continue when we're going to be doing components of more than one vector at a time.